Hi, today we are looking at starting our electrostatics unit. Now, with electrostatics, some reminders: a negative charge is caused by an excess amount of electrons, while a positive charge is caused by a shortage of electrons. Now, if we've got multiple charges, we have something known as Coulombs Law, which enables us to determine the force between any two charges. So we've got our force electrostatic, which have in absolute values, because it is, of course, going to have directions, but depending on how our charges are oriented with respect to each other and the signs of them, the directions will all be different. So for force electrostatic is equal to K times Q1, Q2 over R squared, where Fe is our electrostatic force in newtons, Q1 and Q2 are charges measured in coulombs, and R is a distance in meters between the charges. And lastly, K is Coulomb's constant, which is 9 times 10 to the 9 Newton meters squared per Coulomb squared. Now, the force itself can either be attractive or repulsive. If the charges are both negative or both positive, then the force is repulsive. So if you have like charges, they repulse each other. If one charge is positive and one charge is negative, then they are attracting each other. And from Newton's third law, these forces are going to be acting in opposite directions on each charge. Now, we're going to look at an example. So calculate the electric force between two charges of 2 times 10 to the negative 6 coulombs and negative 2.5 times 10 to the negative 6 coulombs that are 5 centimeters apart. Q1 is 2 times 10 to the negative 6 coulombs. Q2 is negative 2.5 times 10 to the negative 6 coulombs. Our distance between them is 0.05 meters. And we're looking for electrostatic force. So we have our forces K, Q1, Q2 over R squared. In this case, we don't have to rearrange our formula. We have all of our values. So I would substitute our values directly in. And then follow bed mass and solve. So in this case, we got 18 newtons. So we have an attractive force of 18 newtons. Now when you are utilizing this formula, because like I mentioned, it's calculating the force between any two objects, and depending on, and it can be any which direction, so negative or positive of our force is going to indicate whether it's attractive or repulsive force. So whenever we get a negative out of it, just means it's going to be an attractive force, and anytime we get positive out of it, it'll be a repulsive force. Okay, next example, calculate the charge on P if the net force acting on a negative charge is 0. So first thing, I will label those charges. So I'll call it charge 1, charge 2, charge 3. So charge 2, we know the net force acting on it is 0. And writing out our charges, we know charge 1 is 4 times 10 to the negative 6 coulombs. Charge 2, it should say, sorry about that, is equal to negative 1.0 times 10 to the negative 6 coulombs. Charge 3, we're looking for. Radius between 1 and 2 is 3, and between 2 and 3 it's 1. Now we know our sum of forces is equal to 0. Our sum of forces acting on 2 is 0, which means that force between 1 and 2 minus force between 2 and 3 must equal 0, which means those must be an equal magnitude. So we can say KQ2 Q3 over R2 free squared equals KQ1 Q2 over R1 2 squared. You'll notice that both sides have K, so that's going to cancel out, and both sides have Q2, so that will cancel out. At this point, we want Q3 on its own, so we'll multiply both sides by R2 free squared. Substitute our values in, and we get 4.4 times 10 to the negative 7 coulombs.